my channel.
Right, guys, I want us to talk about epimers. So when we are talking about epimers, they are actually pair of compounds or pair of molecules that differ at one configuration. Okay, so let's take example to be glucose. So let's say we have our glucose to be here. This is our glucose molecule. Within our glucose molecule, we have our carbon, which is bonded to oxygen, and our hydrogen. Glucose is an aldose. It's an aldose sugar. This means that it contains the aldehyde functional group. Now, let's represent our OH and our H group with some colors for it to be very specific. Now, this is our second carbon, our third carbon, our fourth carbon, our fifth carbon, and this will definitely be our sixth carbon. So let me reduce the length of my structure. Yes, so this is my sixth. So now, if here is supposed to be OH group, so let's represent here to be dot, this one also to be dot, but we'll be representing it with colors for it to be more distinct. So now we have our circle here, 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 and also our circle here. So now let's try and differentiate it with colors. Wherever we see our OH group, let's represent it with color red. So now this is OH group, this one too is OH group, this is OH group, this one too is also OH group. Now, how many carbons are we having? We are having 1, 2, 3, 4, 5. Instead of me drawing 6, I drew 5. So this one will no more be glucose. Let me try and add another one to it. So now this one, me add the 1 to it. Now I've extended the structure. Now I'm having another O, and this one will definitely be my what? Another O. So this one will no longer be a glucose molecule. Now, for me changing the colors, let me try and change this color. So now, let's say we are no longer dealing with glucose. Later we'll draw glucose so that we understand it. Now let's represent this one to be an OH group again. So automatically this one will be a sugar molecule, but we don't know the sugar molecule. We've drawn it, but we don't know the sugar molecule, just for a graphical representation of the epimers. So now here is our hydrogen, represented with color green. Hydrogen, 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 and hydrogen. Alright, so this one that you're seeing here, let's say this one is a sugar molecule. We don't know the actual name, but let's call it, let's say, because the OH group is on the right, let's call it D. Let's see this one as D manus. Though it is not manus, let's call this one D manus. So now if this one is a D manus, let's try and draw the epimer of it. When you're talking about epimers, they only have a change in configuration at only one side, which means that there is a change in configuration at only one point. So now let's try and draw its epimer. Let's say we are drawing the same structure, but just that there will be a change in configuration at carbon 3. So now let's try and draw it. So now we have our same molecule, now we have our C double bonding with O and our hydrogen. Very interesting. Now let's try and do it again. We are drawing the same molecule, just that there will be a change in configuration on the 3. So right now that we are having our OH group to be here, let's try and change our OH group. So our OH group is still here. So this is that there is a change in configuration. Now where we are seeing our O, let's put the OH here. We are having our OH here. Let's draw the same thing. Now this will be hydrogen, 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 hydrogen. Okay, so right now let's name this one. Let's see, because the OH group is still on the right of the penultimate carbon. This is the penultimate carbon. I've already discussed it with you. So let's say this one is also D, but let's call this one galactose, even though it is not galactose. Let's call this one galactose. As you can see, this means that the molecules are not the same. There's a change in configuration as carbon 3. For that matter, we can say that D-galactose is the same thing as what? C3 epimer. C3 epimer of D manus. Very interesting. You see how it is? The same way we can also say that D manus is also what? A C3 epimer of what? D galactose. All they are trying to say that on the third carbon there is a change in configuration. There is only change in configuration at the third carbon. After all, they are all bonded to the same atom, the same group of atoms, just that the arrangement in space changes. So now this is what we call epimers. There's a change in configuration. Let's try and draw or bring it into reality where we are going to draw glucose. So now let's try and draw our glucose molecule. So this, let's try and draw glucose. Let's separate our sheets. So now this will be glucose. This right here will be glucose, where we'll be having our carbon bonded to here, having our H, then O, 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 O. So 1, 2, 3, 4, 5. So our last carbon, let's say this one to be O, O, and O. Okay, so now let's try and draw the row structure for glucose. This one is glucose. We are having our hydrogen here, then our hydrogen, and probably our hydrogen. You see, then this one will be another hydrogen. So from there we have our OH group to be here, OH group, then OH group, and also OH group. So this is how we are actually dealing with. What you have to note is that this is our penultimate carbon. This is our penultimate carbon, the last chiral carbon along the chain. This one is not a chiral carbon because you can see that there is two identical group of atoms that have been bonded to it, so it's not a chiral carbon. Now you can see that this one, the OH group is on the hot, on the right, so D glucose. So this is the original structure for D glucose. Let's try and draw an epimer of it. Let's try and change the configuration at 2. So if you change the configuration at 2, let's try and see what will happen to it. No, this one is 2. This one is 3. This one is 4. Let's try and change the configuration at carbon 2. If we change the configuration at carbon 2, we are going to get something like this. This is what we are going to get. Let's try and change the configuration at carbon 2. So if you are changing the configuration at carbon 2, this means that if the OH group was at right, we are going to change it to left. So right now our OH group will rather be what? Will be left. Same thing applies here. You only change the configuration at carbon 2. Apart from that, there is nothing else again. Now, this is also our OH groups. The configuration of the molecule is actually D because we are having our OH group on the penultimate carbon to be on the right, so still D. Now, this one is not a glucose because we can see definitely that there's a change in configuration. If there's a change in configuration, it doesn't make it glucose again. It changes its structure, it changes its connectivity in space. It also changes its properties, especially its chemical properties or its physical properties. So right now, we don't call this one glucose again, but we call this one D-mannose. D-mannose, as you can see here. So if that's it, then we can see that what is the relationship between A? Let's say this one is A and this one is B. So what will be the relationship between relationship? Oh, my pen is not working. Let me see where it will come. Okay, yeah. So what is the relationship between A and B? This one is B. This one is also A. The relationship between B and A is that they are epimers. Epimers in a sense that they only change in configuration at one chiral center. And these epimers, we can say that they are what? C2 epimers of each other. The C2 actually represents the place where there is a change in configuration. So we can say that D-glucose is also the same thing as what? C2 epimer of what? D-mannose, or D-mannose is the same thing as C2 epimer of what? D-glucose. That is very interesting, as you can see here. So let's try and change the configuration at carbon 4. If you try and change the configuration at carbon 4 with respect to our molecule A that we've drawn here, this will be the original structure. This one is our seed carbon, our fifth carbon, our third carbon, our fourth carbon. No, this one is our fifth carbon, and definitely we are having our C here, OH and H. Now let's try and change the configuration at carbon 4. So if you are changing the configuration at carbon 4, here this is carbon 4. Now let's try and change the configuration. So this is that the hydrogen here will no longer be there again. Our hydrogen will rather be here. So this it will be where the hydrogen will be. Apart from that, everything still remains the same. Everything still remains the same, as you can see here. Now let's try and see something here. We have our OH groups too also here. Now there's a change in configuration at carbon 4. So still a D glucose, still a D sugar because of the OH group on the right. Now we can't call this one mannose because the configuration was not at carbon 2. We can't call this one also glucose because there's a slight in configuration at carbon what? Carbon 4. So now this one will rather be called what? D-galactose. So this is how actually epimers work. Epimers, they are all about pairs of compounds that are having a change in configuration at only one chiral center. That is all about epimers. So try and change the configuration at carbon 3 and determine the name. Also change the configuration at carbon 5 and also determine the name of it. If you are able to do that, and also make sure that if you take glucose and you change the configuration at carbon 5, what do you think it will happen to it? I also expect that answer, or you have to find that answer yourself. This time around, it's not be giving you an epimer though. That is the right solution. It's not give you an epimer, but it's going to give you a name. So try and find that name too. So I'll be continuing with diepimers where there will be a change in configuration at 2 chiral carbons Also try epimers. There are a lot of terms that are associated with it. We have epimer, we have diepimers, and we have triepimers. So if this video finds you very important, try and actually subscribe to my channel. Yep. And also, if you've not liked, try and like the video as well. Any challenge that you're having, try and post it under my comment section, and I'll make sure I help you out with it. Thank you very much for watching my video. This is Jellyverse once again. Thank you.